So we have completed the Docker. Okay, now if you see Docker, Kubernetes, both are like interlinked concepts. Like you know, in Kubernetes you will use the Docker concepts. Like without a Docker you cannot use the Kubernetes. Okay, in Docker generally uh, we will use a concept called container. Okay, but in case of Kubernetes we will use a concept called pod. Okay, so what is the difference between container and pod? See, generally pod is a collection of or combination of containers. Okay, that means pod can have multiple containers in it. Okay, so if you take one pod, that pod will have the multiple containers inside of that. Okay, or you can also have single containers. Okay, pod can also have single container, and also it can have the multiple containers. But if you see, most of the times we always use single container. We always use a single container in the pod. Sometimes we will use 2 or 3 containers. That's it. We cannot use more than that. You can use, but there is a that feasibility. You can use multiple containers in it, but if it is 2 or 3, that is okay. But it is more than that, it will create issue in that pod. Okay, always limit the containers in the pod. It is better to use single container in that. Okay, but you will use 2 or 3 containers in specific cases. I'll tell you what are the specific cases also. Sometimes you want to use the logging, or like you want to, for example, you want to give the authentication to the pod. Okay, if you want to give the logging and if you want to give the authentication to the pods, in that case you can use 2 or 3 containers. That is what let me open this one. I'll explain here. Okay. See, let us take this is a pod. Okay, now this is my one container. Okay, now let us take this is one more container. This is one more container. Okay, this container is the application container. Okay, application container. What is the meaning of application container? Your actual code, okay, your service. Okay, let us take a payment service. Okay, that payment service code will be here only. It will be there in application content. That service code, the application code, the main code will be in the application container. Okay, but if you want to check the logs of the container, okay, if you want to check the logs of the container, then you can use one container here for logging purpose. For logging purpose, you can use one container here. And you may get one doubt, why we can check the logs from this container itself? Why can't we use the logging also in this container itself? Why? Because if you use the logging also in the application container, what will happen? It will increase the load on the application container. You will always try to check the logging, you always try to check the logs of this container. Okay, and whenever you want to get the logs from this container, you always perform some actions on this container. These are like a burden on this container. Okay, so you want to reduce the burden, extra burden, you want to reduce it. You don't need, right? Actually, logging is not a mandatory thing. What is the purpose of container? It will deploy the services, features, application code, microservices, right? So that is the only task of this. But for monitoring, for checking health conditions, for all these things, we are using logging. But this logging is the extra load on this, right? So we need to eliminate this extra load. That's why we will create one more container, and these two containers will talk with each other, because both the containers are in the same pod. Within the same pod, all the containers will share the same namespace, will share the same namespace, and will share the same network. Okay, so that means both the containers can communicate with each other. So this logging container can get the logs from this application container, and whenever the user wants to let me take this one. Whenever this user wants to take the user means any DevOps engineer or any developer who wants to see the logs of this application container, he can simply access logging container. Okay, not the application container. If he will access the application container, that will increase the burden on this application container. Okay, so this logging container will connect with this application container by the default network within the pod. Okay, so this logging container will reduce the burden on this one, but it will increase the burden on pod. And also you have one more container. Let us take, there is one container for authentication. Okay, there is one container for authentication. Okay, so you will not always use authentication containers, you will not always use logging containers. Okay, I'm telling you the specific cases. Okay, sometimes, for example, let us take, this is a payment container. If it is a payment container, then it should have some authentication. It should authenticate the users, right? So in that case, you have to give the authentication container. So users directly users directly contact with this authentication container. Okay, they will directly contact with the authentication container. If authentication container gives an access to this user, then he can able to access the container, application container. Okay, and also few more containers you can add here. Those are like based on your requirements only. Okay, so like this, the pod contains multiple containers, and a single container also you can use. I think you understood, right, what the pod and what the container is. Okay, now, so this is what about pod. Okay, now we'll see the introduction, what is where the Kubernetes, where it is originated from, and what is the Kubernetes, and we'll see all these things. Okay, Kubernetes is open source container orchestration platform. Of course, all the DevOps tools are open source tools. Mostly 75% of the tools are open source tools. Okay, Docker is also open source, Git is also open source. If you want to get the premium one, you can get the premium, there's no issue, but these are open source tools. Okay, and it is an orchestration platform. What is orchestration? I already told you, right? Orchestration means it's orchestrating the containers. That means organizing the containers. That means in which node we need to deploy the container, which container we need to deploy in which node. Okay, based on the healthiness of the node, based on the healthiness of the container, we will manage the nodes and the containers. That is what orchestrating. Okay, so why we are using orchestration? We are using orchestration for automating deployment, the scaling, management. We have seen all these things in the Docker Swarm also, right? Now here, this Kubernetes, actually initially it was developed by the Google. It was initially developed by the Google, and then it sold out this this Kubernetes to the CNCF. Okay, now CNCF is managing this one. Okay, Cloud Native Computing Foundation is maintaining this one. And see, this is released on 2015 only. It's all hardly 2 years, 7 years. 7 years back it has came. 7 years back it has come. Okay, so that means it's very new tool, right? Kubernetes is very new tool. So still research is going on that, still development is going on that in the Kubernetes. So still multiple features are adding in this Kubernetes. So no one is perfect in Kubernetes, everyone is new to Kubernetes. Okay, so there are a lot of things to learn in Kubernetes, because you know it's like an ocean. If you want to become administrator, if you want to become a certified Kubernetes administrator in this, you need to spend around 3 to 5 months to become a certified Kubernetes administrator. There are a lot of things, because like you know, you will have horizontal pod auto scaling and Helm charts and CRDs, custom resource definitions, and integration with the Prometheus and Grafana, and like you know, like lot more things will be there. It's like an ocean. We cannot say this is the syllabus for Kubernetes. We cannot say this is syllabus for Kubernetes. You know, so you know, I'm going to give you the necessary things only. Okay, these are sufficient. You can work on your project, day-to-day life. You can work on with these things. Okay, but you want to become administrator. You cannot work with these things. Whatever the concepts I will explain in this session, those are not sufficient if you want to become an administrator. If you want to become an administrator in the Kubernetes, you need to spend 3 to 5 months only on Kubernetes. Okay, but it's very silly thing, right? For complete DevOps, we will take around 2 to 3 months to completely learn the DevOps. But for Kubernetes itself, it will take 3 to 5 months. That you know, that is you know, very demanding tool. That's why you know nowadays everyone is going to get the certification in the Kubernetes. Very vast concept Kubernetes. Okay, so this is all about the introduction of this Kubernetes. Okay, now see here this why Kubernetes. Already we have seen the introduction part of this Kubernetes. Now see why Kubernetes. Already we have seen that Docker Swarm. Why use the Docker Swarm? We have seen. But when compared with the Docker Swarm, it is offering multiple features. What are those features? The scalability. Scalability is very high. Okay, but in Docker Swarm, the scalability is very less. Okay, we cannot use it for the complex projects, large scale projects. But this is Kubernetes we can use this for the multiple projects. Okay, and the portability. Portability is like you know, you can use the Kubernetes on premises and cloud also. In any environment you can use, like you know, you can use it in AWS, you can use it in GCP, in any cloud you can use this. So that much portability it will give. Okay, and high availability. I already explained you what's the availability and all these things, right? I already explained you. Okay, it will give high availability. Okay, and resource efficiency, because you know Kubernetes will offer you like how much CPU you can use, how much RAM you can use, that you can limit it while creating the one. See, in Kubernetes you will write some YAML files, some configuration files for the pods, services. Okay, like different kinds of things will be there. So for those things you will always write the YAML files. Okay, so in the YAML files you will specify how much configuration we can use for this pod, how much configuration we require for this pod. We can limit all these things. Okay, we need only 1 CPU for this pod, we need only 1 GB RAM. We can limit those things in the YAML file. So we can efficiently use the resources by using the Kubernetes. Okay, so and also community and ecosystem, like you know, multiple you know, the ecosystem, it is like an open source tool, right? So everyone is working for this Kubernetes. Okay, open source project. I already explained you in the gate. Like you know, whenever you want, see forking, in the forking concept I have explained, right? If there is a open source project and if you want to contribute something to that project, you can contribute by forking that project, forking that GitHub code to your repository, and you can work on that project, and you can just simply raise the PR. If that PR is if this PR is very helpful to that project, then that owner of that project will be will accept that PR, and it will be merged to the project, right? Forking will work like that, so like that only, right? Similarly, here the ecosystem, the Kubernetes ecosystem is very large. Multiple persons will work for that Kubernetes open source project, and they will keep on adding the features to the Kubernetes, and the community is very vast. Okay, and also you can see the documentation part. Kubernetes will have the good documentation part. You don't need to remember anything. You just simply go to the Kubernetes documentation and simply use that documentation for writing the YAML file. You don't do anything. Okay, no DevOps engineer will do all these things. No DevOps engineer will not remember anything. Okay, DevOps engineer will not remember anything. He will simply use the documentation, and he just will follow the documentation. He will know the flow, how to do that, what to do that, he will know. That is enough. You don't need to remember all these things. Okay, and Kubernetes will give you good support. Okay, good documentation, and you will have monitoring tools, logging tools. Like if you take the monitoring, you will have Prometheus and Grafana. Okay, and for logging you will have Elastic Logstash, ELK. Okay, so these many tools will be we will use, okay, for checking, monitoring and logging. We will integrate those things with the Kubernetes. So that's why this community and ecosystem is very huge. Okay, now if you see the features of this Kubernetes, this is the container orchestration tool. We can do container orchestration. Okay, we'll do automated load balancing by using the services in the Docker Swarm. What we have done, we have created one service, and the service will distribute the load across the multiple containers in the multiple nodes, right? So the service will act as a load balancer, right? Similarly, in Kubernetes also we will have the services. Okay, the services will act as a load balance, will do the load balancing, automated load balancing. Okay, and here we can see self-healing can be done. I think the self-healing can be limited to the pods only. I think it cannot be applicable to the nodes. Okay, I think it can be it is limited to the pods only. If any pod fails, then it will be automatically healed. Okay, and we can do rolling updates and rollbacks. If you want to switch to the newest version, then you can just you can use the rolling update. And if that newest version is not working properly, then you can do rollback to the oldest version. Okay, so those things also you can do with Kubernetes. And storage orchestration you can also do, like in Docker, what we have used the Docker volumes and the bind mounts, right? Similarly here Kubernetes also, we will have multiple storages you will have. Okay, not only Docker volumes and the bind mounts, you will have the config maps, you will have the secrets, you will have the persistent volume claims. You can use the ABS, you can integrate with multiple third-party tools with this Kubernetes for the storage purpose. So vast resources will be available for the Kubernetes. So the storage orchestration also you can do with this Kubernetes. Okay, and the service discovery, what we have seen in the Docker Swarm, in the master node we have a service discovery. In that service discovery, with the service discovery we can find out the containers, which container is executing which service. We can see those things. Okay, by using the labels and the selectors, right? So similarly here also we will use the labels and the selectors. By using those labels and selectors, we can discover the services. So that service discovery facility will be also there in the Kubernetes. Okay, and the configuration management. What is the configuration management? Configuration management is like, for example, if you want to install Nginx server, or if you want to install the Apache server in the virtual machine, any EC2 machine, what you will do generally for configuring? Generally you will do manually, install that. Previously we have seen that, right? I have created one virtual machine, and in that virtual machine I have created one container out of Ubuntu. In that container I have I went into that container and I have installed the Apache to server, and I tried to access that Apache server, right? So I have just installed the Apache server manually in that container. But here, see, those things also you can do. See, installing Apache server is nothing but the configuration management, configuring the container, right? So these things also we can do with the Kubernetes. Generally, what we will do is, generally we will use the Ansible or Chef or some other tools for configuring the virtual machines. Okay. So this Ansible will, this Kubernetes will also do the same purpose. It will also be used for the configuration management of the pods, not the virtual machines. Okay. But Ansible will be used for the configuration management of the virtual machines, not the pods and all these things. Okay. Now, Kubernetes is offering a very good thing, that is what secret management. Sometimes you will deploy some application. That application will access the secrets, some sensitive data it will access, some database details or some other credentials it will access or it will store. Okay, so whenever the hacker tries to access that pod or that cluster, Kubernetes cluster, so it should be very careful. Like, we don't need to expose that credentials to the third party, okay, users. We don't need to expose that. The user should only access the front end only. That means the user can access the UI part, okay. That console he has to access, not the backend part, okay. He should not access the backend part. So we need to make it secure. So for that we will use a secret management. There we have a concept called secrets and config maps in the Kubernetes. Okay, I will give you the brief about the secrets and the config maps. Actually, those are not in the syllabus because I want to tell you something more. Not in the syllabus. I want give you more in that. Okay. So I always I always give my best. Okay. So till now I have explained everything about the Docker, but those things are not included in the syllabus. But I have explained everything. Here also Kubernetes also I will give you more stuff I will give you. Okay. I will explain the secrets and I will explain the config maps also. Okay. Those are very interesting concepts. So that's why I will explain it. It will be very useful to you. And then resource management also. It can help. Kubernetes can manage the resources. Okay. Like multiple resources are there. Like configs, config maps, secrets, deployments, replica set, ingress. Multiple resources will be there. Those resources can be managed by these Kubernetes. Okay, and this Kubernetes also, we can use this Kubernetes with multi clouds. Okay, this Kubernetes can combine all the multi clouds. Some nodes we can use in one cloud, some nodes you can use in one cloud, and you can combine these two clouds as one cluster. Okay, cluster cannot be in a single cloud. Cluster can be in multiple nodes also. That is very advanced concept. Okay, so it can be used for multi-cloud and hybrid cloud. Hybrid cloud means what? Cloud and the on-premises. Okay, so those things also it can do. Okay, and health checks, you will provide the probes. Health probes will be there in the Kubernetes YAML file. You will specify the health probes. Okay, based on that healthiness of the pod, we will assign the task to the pods. If that pod is not performing well, if the pod health is not good, then we won't assign task to that pod. Those things we can do with this Kubernetes. And monitoring and logging, I already explained you. For monitoring, we will use the Prometheus and Grafana. Okay, and for logging, we will use the Elastic Logstash. Okay, and some CloudWatch tools. Those tools you can integrate with the Kubernetes. Okay, and security, it will offer good security. Okay, by the networking and all these things. Okay, so these are all about the features of the Kubernetes. Okay, now see types of Kubernetes distributions. What are the types of, like, in the market we will have multiple Kubernetes distributions. The most popular one is OpenShift distribution. You can simply install your Kubernetes software in the OpenShift and there you can use it. Okay, so and then Rancher. Okay, Rancher is a one of good distribution. Okay, and now uh, AKS, EKS, and GKE. These are the cloud platforms. AKS is the Azure Kubernetes service, and EKS is the Elastic Kubernetes service, which is in AWS, and GKE is the Google Kubernetes engine. This is in GCP. Okay, this cloud also offering some distribution, like these are also distributions for the Kubernetes. You can also work on here also, okay, for creating the Kubernetes cluster and for deploying the pods. Okay, and micro K8s, Minikube, K3s, K3D kind. So these things are like for development purpose we will use. Okay, micro K8s, it will generally use a single node concept. Like you can use the Kubernetes in single node also. Okay, so single node can be useful for development and testing purposes. We cannot use the single nodes for the production, right? Because if the application is very huge application, then how we can deploy that single application, that huge application in a single node? So very risky thing. So that's why we cannot use these things for the production purpose, micro K8s and all these things. Okay, and Minikube is a very famous tool, very famous distribution. If you want to do practice, just simply you can install the Minikube. It will give you only one single node. In that single node, you can just simply practice the Kubernetes. Very famous. Okay, for the practice purpose, you can use this Minikube. Okay, you can simply go to the Google and you can simply see the commands for installing the Minikube. Okay, you can simply install Minikube. Hardly it will take 1 or 2 minutes to install this Minikube. That's it only. Okay, so and K3s, K3D, and some other things will be there. Okay, and you can also do Kubernetes in Docker also. Docker is also providing some Kubernetes feature. You can also do this in Docker. That is what we can call as a kind. Okay, Kubernetes in Docker. Okay, but these things will offer only single nodes. That's why we are not using these things in the production. Remaining these things will be used for the multi-node concept. Okay, so these are the distributions. Okay, but if you see, let me open my notepad. You can see you have distributions. In these distributions, you can install the Kubernetes. Okay, you can install the Kubernetes. And also one more thing, if you take EC2 is a server instance, a virtual machine, right? So in this virtual machine also you can install the Kubernetes. Okay, if you take the EKS, EC2 is also a AWS service. EKS is also a AWS service, but this EKS will provide Kubernetes. This is also for Kubernetes. Okay, we can do all the Kubernetes operations in the EKS, and we can also do Kubernetes operations in the EC2 after installing the Kubernetes in the EC2. Okay, this is like a bare server. It's a bare server, nothing is there in that. It's a bare server. First you need to install the Kubernetes, and then you can do the Kubernetes operations. But how you can install the Kubernetes in this EC2? You can follow different installing tools will be there. Okay, the most famous tool is K8S. Kubernetes operations. Okay, we will use this we can use this Kubernetes operations tool for installing the Kubernetes in the EC2. And also this K8S is recently became popular, but before this we were using KubeDM. Of course, still we are using KubeDM also. KubeDM is a tool. We will use this tool to install Kubernetes in the EC2. Still we are using KubeDM, but nowadays the K8S is more familiar, more famous. Okay, but if you don't need these things, you can simply use the EKS. Why? Because if you use the Kubernetes in the EC2 and if you face any issues in the Kubernetes, then you won't get support from the Kubernetes. You won't get support from the AWS. Okay, See, for example, let us take EC2. You have installed the Kubernetes by using the kubedm tool, and now the Kubernetes is working fine. After some time, Kubernetes is not working. Now you want to get the support. So to whom you will ask the support for? You will always ask for the AWS, right? Because you are using this EC2 in the AWS. Then AWS, what it will say AWS? If you have any issue in the EC2, then tell me, I will resolve that. But if you have any issue in the Kubernetes, I cannot do that. Because Kubernetes is third party. We are installing that Kubernetes in EC2. Okay, if you have any issue in the Kubernetes, you can't resolve this. You cannot get the support. But if you get the issue in the EC2, you will get the support from the AWS, because EC2 is the AWS service. But if you use the Kubernetes in EKS, EKS is the Kubernetes service of AWS. So if you get any issue in the EKS, then the AWS will help you. AWS can give you the support. So I recommend that better to use EKS instead of this bare EC2. Okay, because installing Kubernetes will take a lot of time. It's a very complex process to install Kubernetes in the EC2. Very complex, seriously very complex. And if you take EKS, it won't take that much time.
Ramana.
Yes.
EKS also, it's part of AWS services, correct?
Yes, it's a part of AWS service. Okay.
Both are instance services only.
Sorry?
No, both are part of instances only. Services.
So actually EC2 is a server. Okay. EC2 is a server. It's a elastic compute service. It is server. You can do anything here. It's a bare server, empty server. You can use this EC2 whatever you want, you can do in the EC2 server. Anything you can do in the EC2 server. Whether it is Kubernetes, whether it is Docker, whether it is Ansible, whether it is Grafana, Prometheus, anything you can do is EC2 service. But EKS you can do only Kubernetes. It is only specific to Kubernetes.
Yeah, that's what I mean. Only specific to Kubernetes.
Only specific to Kubernetes. Okay. So if you get any,
but it will act like EC2 instance, correct?
It will not act like EC2. It will use the EC2.
EC2, okay.
It will use the EC2. Why? Because you will create the Kubernetes cluster, right? Cluster means what? Cluster means combination of nodes, right? Whenever you use the EKS, this EKS by default, it will create the cluster, and this cluster will have the nodes, and these nodes will be managed by the EKS itself. We are not managing nodes. Okay, these nodes will be managed by EKS. What are the nodes? Nodes means nothing but EC2 instances. Nodes means nothing but EC2 instances, EC2 servers. Okay, these servers are managed by EKS. We are not managing it. But if you use the Kubernetes in the EC2, you are installing that, and you are creating the cluster. That means you are going to managing the EC2. That is somewhat complex thing. That's why you always try to use the EKS. You will get the support. You don't need to do any extra. You don't need to give an extra effort. Okay, EKS itself will manage the nodes. For example, if the load increases on this cluster, then what it will do? Automatically it will increase the node. Automatically it will increase the number of nodes. Okay, based on the load. So that is the use of this EKS. Okay. Similarly, AKS also, it is in Azure, it is in AWS, it is in GCP. Okay, those are the cloud platforms. You got it right? Now,
yes, got it.
Yeah, okay, fine. Now, if you see, we want to see the differences between Docker Swarm and the Kubernetes. Why we came up with this Kubernetes? The first feature is, if you take the installation and the configuration part, cluster configuration part, Docker Swarm is very easy. Why? Just only one command, Docker Swarm init -, advertise address equal to public IP address of the master node, and it will generate the token, and if you give the token to the slave node, that's it. It will create the cluster, right? Very simple. But if you see Kubernetes, very difficult. I'll show you those things also. Very complex. Sometimes, we are not able to create the cluster also. You will get a lot of errors. seriously will get the lot of errors. If you use the kubedium or KOps, you will get a lot of errors. We are not able to create the cluster properly. That's why we are always go with EKS. Okay, EKS is very good thing. Or if you want to go with OpenShift, you can go OpenShift, Rancher, all these things. But I will recommend you to go with EKS, AKS, or GKE. And in this EKS, AKS, GKE, GKE is very good. In my project, actually, I have used GKE. It's a very good thing. When compared with EKS and AKS, GKE is very good. It will provide some cloud shell it will provide. That is very good. Very user friendly and very easy also when compared with these things. I'm very happy with this GKE. Okay, in the GCP cloud. Okay, so let me open it. The installation part is very complex in the Kubernetes. Okay, now GUI. Okay, for Docker Swarm we won't have any GUI, any console we won't have. Okay, but in Kubernetes we can create the Kubernetes dashboard. From there you can simply do all the operations, all the Kubernetes operations. Okay, you don't need to use the command line. Okay, if you have a dashboard, you don't need to use the command line. As like if you take Docker, there is a Docker desktop. There you can simply use the Docker desktop and you can simply pull the image, you can simply push the image, you can modify the image, everything you can do with the Docker desktop. But in the Docker Swarm, you won't find that GUI. Okay, so that is a one added advantage in the Kubernetes. And scalability is like highly scalable and scale fast, but when compared with the Docker Swarm, it is somewhat less. Kubernetes, because the Kubernetes is a complex structure, right? So that scaling will take time. Okay, but here if you see the Docker Swarm scaling is very fast, faster than Kubernetes. Okay, and Docker Swarm cannot do auto scaling. We cannot do auto scaling. Okay, so if the load is increased, it cannot create a container, extra container. We need to create the extra container. If the load is increased, we need to create extra container, and then we can route the traffic to that extra container in the Docker Swarm. But it cannot do auto scale. But Kubernetes can do auto scaling. We will use the horizontal pod auto scaling. Okay, HPA. Okay, that's very important concept in Kubernetes. That is advanced concepts, of course. So it will horizontally like there are two concepts like horizontal pod auto scaling and vertical pod auto scaling. Okay, so those things will be used in the Kubernetes for auto scaling purpose. If you see load balancing, see this point is wrong actually. This point is wrong. Load balancing is wrong. I'll tell you why. Kubernetes will not require the manual intervention for the load balancing, but here it is mistake. Okay, so this actually this should be Docker Swarm, this should be Kubernetes. It's reversed actually. Okay, Kubernetes do auto load balancing. Of course, both will do auto load balancing, but when compared with the Docker Swarm, Kubernetes is somewhat good for in the load balancing. This point is wrong. Okay, you don't need to consider this point. Okay, just see Kubernetes will do good auto load, good load balancing. Okay, Docker when compared with the Docker Swarm. Okay, now next rolling updates. See, we can do rolling updates in both the things, but in Kubernetes we can do automatically. Okay, but here in Docker Swarm we cannot do automation for the rolling updates and the rolling rollbacks. Okay, I think no, but we cannot do rollbacks automatically in Docker Swarm. I think we can do rolling updates automatically in the Docker Swarm. Let me check this one because I'm not sure about this. But Kubernetes rolling updates and rolling backs can be done automatically. But maybe Docker Swarm I'm not sure because I didn't use the Docker Swarm till now. Okay, so Docker Swarm I think it will provide the automatic rolling updates but not the automatic rollbacks. Okay, and when compared to data volumes, it's very good. Okay, so Kubernetes will offer a lot of features for the data volumes. Okay, like you will have the config maps, secrets, like persistent volumes and persistent volume claims, and you can also integrate the EBS and some other extra third-party tools also you can integrate with this Kubernetes. But here in Docker Swarm, you cannot do all these things. You can simply use the Docker volumes and the Docker bind mumps, I think. I'm not sure about this Docker Swarm. Okay. And for the logging part, Kubernetes by default, it will have the logging and monitoring tools. Okay, Prometheus and like Elastic Logstash and all those things. By default, there in the Kubernetes, you just need to mention those things in the YAML file. Okay, like these are like a CRDs, custom resource definitions. Okay, so these definitions, these resource definitions, you need to mention in the YAML file. Then only you can able to use those monitoring and the logging tools. Otherwise, you cannot to use those things in the Kubernetes. But by default, those are there in the Kubernetes. But in Docker Swarm, you won't have those tools. You need to use the third-party tools for logging and the monitoring. Okay, so that is the differences. Those are the differences between the Docker Swarm and Kubernetes. So those are the differences. Now let us see the Kubernetes architecture. Very, very important. This is very important. In every interview, in DevOps interview, it's a mandatory question. And also not only about the interview, you should know the background process of this Kubernetes, how this Kubernetes will work and all these things. What is control plane, what is data plane, how the worker nodes will work, what are the components it will contain, and what are the functions of each component, how they will send the traffic, how they will get the response back. All these things you will see here. Very important Kubernetes cluster. Okay, so here if you see, this is the control plane. Okay, control plane means what? It will control the nodes, it will control the slave nodes, it will control the worker nodes. Okay, so control, this is the control plane, this is the data plane, complete thing. Okay, this is the data plane. Okay, like data plane means this is one node, this is one node. Okay, so this is the data plane, these two nodes included in the data plane. You can not only two nodes, you can use multiple nodes, hundreds of nodes you can use. So all these things we can combine as a data plane. Data plane will do all the works, all the jobs it will do. Okay, so here the control plane will have some components, worker node will have some components. So let us see one by one. Okay, first etcd cluster. Okay, so every control plane, that means every master will have is etcd cluster. What is the use of this etcd cluster? It is nothing but the storage. It is nothing but the storage. This storage will be like, it will be like in key value pairs. Like how it will store the data? It will store the data like this, key and some value. In this format it will store. Okay, like for example, how it will store? For example, username, and here you will give the username and password. Here you can give the some password. So like this, some key, some value. In this format it will store the data. Okay, so it will store the data. Okay, so for example, what kind of data it will store? etcd it will store the configuration related data, like how many nodes it will have, what is the IP address of this node, what is the domain of this, what is the host name, what is the gateway, what is the network gateway, what is the subnet mask, how many networks it will have, how many volumes it contains, so how many containers it will have. All the data will be there in the etcd. The complete custom configuration will be there in the etcd. Okay, and also it will also save some sensitive data also. For example, if this worker node needs some information, some credential information, then how it will get? First it will try to go to this master node. In this master node there is an API server. Okay, API server will be generally used for the communication purpose only. Okay, so it will send the request to the API server, and this API server will send it to the etcd. If this etcd approves that request, if etcd approves, because here we will set up lot of security for this etcd. Kubernetes will offer you lot of good security it will offer. So here for the etcd we will give lot of security, lot of layers, security layers we will add to this etcd. Okay, So whenever this worker node sends the request through API server to etcd cluster etcd, this etcd, it will first recheck whether this request is correct or not. This request is from the correct endpoint or not. First it will verify that. If it is from the correct endpoint, it is from the within the cluster, then it will accept the request and it will send back the response to the worker node through API server. Okay, API server will be the like the communication component. It will just communicate with all the components in within the cluster. Okay, so that is the use of etcd. Okay, so if you take the control manager, this control manager will always control the nodes, worker nodes, like how many nodes we have. Okay, whether this node is up or down. If this node is up, then this node is fine. So okay, this node is up, that means this control manager will send some communication signal, some request to the this API server. Okay, this API server now will integrate, will talk with the cluster. Okay, this node is working fine, this node is up. Now if you want to store the data, you can store the data from this node. If you want to give the data to this node, you can give, because this node is up, this node is in our cluster. Okay, you can give that. Like that, it will API server will tell to the etcd cluster. So whether it is up or it is down, it will be controlled by the control manager. Okay, so if it is up, then okay, it is up. Now it will tell you, this control manager will tell to the scheduler through API server. What it will tell? Okay, this node is up, now you can schedule the tasks into the node, because this node is up, you can schedule the task. So these kind of instruction, these kind of request, it will send to the etcd and it will send to the scheduler. Okay, through API server. And and it will also manage the routing. Okay, if this node is down, now it will not do any operations in this node. It will just simply skip this node. Control manager simply skip this node. Okay, you will get the log, you will get that log. Okay, if you integrate the any logging tool, that logging tool will tell you. Okay, because of this, control manager will send that logs to the logging tool. This container is up, this container is down. Because of this control manager only we will get. Okay, now scheduler will what it will do? Scheduler will schedule the tasks to the worker nodes. How it will schedule? First it will get the information from the control manager, and also it will get the information from the API server. Okay, if everything is working good, then scheduler will schedule the task in that node. Okay, if and also there is one thing, this scheduler will do it will follow the rankings. Okay, it will assign the ranks to the nodes. Okay, this node is working well, and some components are not working, so I will give rank to this, rank 2. This node is working very good, so I will give rank 1 to this one. Okay, I will give rank 1 for this node, I will give rank to this one. Based on the ranks, this scheduler will schedule the tasks to the worker nodes. Okay, so scheduler function is to schedule the tasks. Okay, so these are the components in the control plane: API server, control manager, scheduler, etcd cluster. And one more thing is, you should have Docker engine also here. Here I didn't mention, but Docker engine is mandatory. Okay, not the Docker engine, I can say, if you want to say generalized way, you should have container engine, not the Docker engine. Container engine means it can be any container engine, whether it is a Docker engine, whether it can be Rocket, whether it can be Creo. There are multiple container engines, right? But mostly we will use the Docker engine, that's why we are using Docker everywhere. But you can use the Rocket, we can use the Creo, multiple engines will be there. You can use any one of the engine here. Kubernetes will support those things. Okay, so you have to install the one container engine in the master node. Similarly, in the worker node also we need to install the one container engine, because mostly we are using Docker, so we have to install Docker in both master and the slaves. Okay. Now, when it comes to worker node, in the worker node, we will have two components majorly. Okay. One is kubeproxy, other one is a kubelet. Kubeproxy, the function of kubeproxy is to maintain the networking across the cluster. Okay. If someone wants to access the cluster, if someone wants to access the pod, how someone can access the pod without the network? You should give the approvals, right? You should allow someone, right? You should give some security, you should open some ports. Okay. So these things you will do with kubeproxy one. Okay. Some like Calico networking you will use, or you can use the Flannel. Multiple things multiple networking tools will be there. Mostly we will use the Calico network interface. Uh, Calico network interface for this networking. Okay, Calico. Okay, and then Kubelet is very, I can say this is the heart of the worker node, heart of the worker, and API server is the heart of the master node. Okay, why? Because Kubelet will always maintain the pods, whether we need to create the pod, or we need to delete the pod, or we need to update the pod, or we need to any operations, the pod related operations you can do with kubelet. This kubelet will get the information from the API server. Okay, so this API server will send the signal, will send the request to the kubelet. And how this request will get? This request will get from the scheduler will assign the task to the node. Okay, that request will be sent via API server to the node. In that node we have a kubelet, and kubelet will take that request and it will create the pod. But in which server we have to create the pod, that will be taken care of the controller manager. Controller manager will tell to the API server, okay, this API server will send that request to the particular node. Okay, this node is working fine, now you can assign task to that node. That things will be controlled by the control manager. And whatever the request we will send to the worker node, those requests will be taken to those requests will be taken by the kubelet, and this kubelet will do all those operations here. Okay, maintaining the pods and containers will be taken care of by kubelet only. And here also we will have some container engine. Okay, so this is all about the Kubernetes architecture. If you have any doubts, you can ask me here. If you don't have any doubts, I will continue this. Okay. Now next one is a pods life cycle. Okay. Similar, it is like container life cycle. Okay. What you will do in container life cycle? First, you will create the image. Out of that image, you will create the container. And what you will do? After creating the container, you will start the container. After starting the container, you will, if you want to stop, you can stop it. If you want to delete it, you can delete it. If you want to pass it, you can pass it, or you can unpass it. We have seen that containers life cycle, right? Similarly, here we also have the pods life cycle. Okay, so first what we will do is we will create the pod. Okay, after creating the pod will be first in the pending state. Okay, after pending states, after some time it will be in the running state. Okay, if this after running, it may be failed or it may be succeeded. It's a common phenomenon. Okay, it may be failed, it may be succeeded. If this pod is failed, then what it will do? It will be notified by the kubelet. Kubelet will check, okay, this pod is working or not. Okay, this pod is not working, failed. Now this information will be sent to the API server. Okay, see here, this kubelet will check whether the pod is not working or not. Okay, this pod is not working, it will send the signal to the API server, and again what it will do, API server will send the signal to the scheduler. Again scheduler will send one more task to the API server, to the worker node through API server. Again it will create one more pod. Okay, so this is the one. Okay, it will automatically create the pod. That means it will heal the pod. Okay, if this service it succeed, that is okay. Okay, but if you want to delete the pod, you can delete the pod. It will be first in the terminating stage and then it will be terminated. Okay, sometimes whenever create a pod, it will be in pending state. After that, you will face some weird things you can see there. You don't know what happened to that pod. You don't know. It's different kind of errors you can see there in the there. You won't get running state. You won't get pending state. You will get other things. You will get other things. You can see the weird status you can see there. Okay, those things are very common in the Kubernetes. Kubernetes is very complex. The cluster, that architecture itself very complex. So we need to, because it's still developing, right? Some of the components, still those components are fully not developed. Still the research is going on those components. So that's why we will face these kind of issues vigorously, regularly, frequently. We will get those things. But don't mind all these things, okay? Just simply go on. Try to work on it. Okay. So that's why we always try to work on EKS clusters. EKS will take care of everything. Okay. Now what we will do is we will see installation of Kubernetes in EKS cluster. Okay. So guys, I'm telling you, it's a very costliest service. Okay. If you work with EKS, it will charge you more. So if your practice over, then you better to stop this EKS cluster. Otherwise it will charge you a lot. You need to pay those things. Otherwise AWS will suspend your account. Okay. Now how you can install Kubernetes in EKS? Okay. See, let me open. And guys, I'll try to finish the Kubernetes today itself. At least I will finish 70% of 70 to 80% of the concepts today itself. Okay, please bear with me because we don't have much time to finish the DevOps. Okay, so I will take much time, extra time to finish all these things, but Kubernetes will not take that much time, because that's why I have explained you Docker completely, everything, because if you know Docker, Kubernetes is very easy. You can do with your own. You don't need any assistance. I'll give you how to do that and what are the things we have, and I just give you those things. It's simply you can do. You can just simply do R&D, because explain the Kubernetes will take a lot of time, because very huge concepts. We cannot explain everything. We have to do research our own self. We have to do research. Okay, so I'll give you the important things only. Okay, as per our syllabus and all these things. Okay, now we have to install the Kubernetes in EKS. For that, first of all, let me go to my AWS and I will install. I will create one service, EKS. Let's search with EKS. Oh, let me log in once again. Now let me go to EKS. Let us go to EKS, Elastic Kubernetes Service. See, here you can see add cluster. Oh, sorry, yesterday I forgot to stop this cluster. Let me delete this one. I think it will charge a lot. Let me delete this one. Yesterday I have created it. Okay, it will delete the cluster. Cluster has firewall profiles inactive. You can delete the firewall profiles, and okay. So okay, I'll do this later. Okay, because I have set up the target profiles for this cluster. Okay, now what I'll do is I will first create the cluster in the EKS. Okay, so how to create the cluster? You can add the cluster here. Okay, guys, I'll tell you, we can integrate this EKS with the ECR. See, ECR is the Elastic Container Registry. It is like similar to the Docker Hub. I already told you, right, yesterday in the yesterday class, we have a few more registries for the storing the Docker images, right? So this is the one of that registry. So here we can store the registries, the Docker images here. So we can integrate this EKS with this ECR. So whenever you want to get the images, those images we can get from the ECR. So always you don't need to get from the Docker Hub, right? So sometimes you will get the images from the ECR also. Okay, so if you are using this Kubernetes with the cloud, then better to use ECR, not with the Docker Hub. Docker Hub is the third party tool, right? So if you face any issues with that third party tool, you cannot get the support properly. But if you use the ECR, if you get any issue with that, and that this AWS will give you that support. This AWS will resolve that issue. So if you use the EKS cluster, better to integrate this EKS cluster with the ECR. Okay, so we'll see. I think this ECR is not in our curriculum, so it will hardly take 30 to 40 minutes. If you want to learn, you can learn those things. Okay, but I will explain this cluster only, how you can create the cluster and how you can install that Kubernetes in this cluster. So I'll do all these things. Okay, I'll do all the setup here. Okay, so first of all, let us take this. Let us create one cluster here. Okay, create a cluster. Okay, and guys, do one thing. If you create cluster here, see here, step 1, step 2, step 3, and here you can see the multiple steps here. Up to here you will have 6 steps. You have to fill all these things, right? It is tedious process, right? It will take a lot of time, right? And sometimes you will not able to create this cluster. Maybe you will get some errors, because if you don't properly fill out this application, you will get the error. So in that case, what you have to do is you just simply use the CLI. You need to use the CLI, command line interface. You have to use it. Okay, so I always recommend you to use the CLI instead of using the console. You don't use the console here. Okay, if you are very much familiar with the console, you can use the console. Otherwise, you try to use the CLI. Okay, in this session I will try to use the CLI to create the cluster. Okay, so now what I'll do is, so before in the EKS cluster, there are some prerequisites we need to follow, we need to use. So what are those prerequisites? So here if you take, these are the prerequisites we have to use. We need to install for creating the cluster. So kubectl we need to install, EKSCTL we need to install, and also AWS CLI also we need to install. Okay, so how you can install those things? Let us see how to do these things. Okay, so first of all, let us go back. This is the cluster, right? It is the previous one. So, I think I have already set up previously. I will remove this one, no worries. First, what you have to do is, let us go to EC2. Here you create one server, one bare server. Okay, so let us launch this instance here, one new instance here for the EKS cluster. From this instance, you will try to do all the operations of this EKS. Okay, so let us create, let us take a name, EKS, or EKS. You can give whether it is a capital letters or small letters, it's up to you. Okay, give EKS dreams cluster. Okay, you can give any name here. Now what you have to do is, take Ubuntu machine. Okay, and take 20.04 version, and you can take T2 medium, because if you use the T2 micro, it is just 1 CPU and 1 GB memory, right? So it is better to take the highest configuration, because Kubernetes will use highest configuration, higher configuration it will use. Okay, so you better take T2 medium. It will have T2 CPUs and 4 GB memory. Okay, and it will charge you. It is not in the free tier, it will charge you. Okay, always try to close or shut down this instance if you complete your session. Okay, so I'm taking T2 medium, and you can take the PEM file, already existed PEM file, and I'm taking edit here. I'm taking all traffic. Okay, instead of only SSH, I will take all traffic. Okay, now 8 GB memory is sufficient. It's a storage. Okay, it's a storage, persistent volume storage. This is for the EC2 instance. Now just launch the instance. Okay, so let me shut down these things. We don't require, I think we don't require this, right? Swarm is completed, right? Let me shut down because T2 medium will charge a lot. Let me terminate this. I don't need these things. Okay, so if let us check whether my server is running or not. Okay, it's still pending state. Yeah, it's now running. Okay, now take the public IP of this server and let us connect to that server. Okay, um, SSH Ubuntu machine. Let's take the PEM file, connect it. Okay, so I'm able to connect it. Sudo -i. Now I'm in the root user. Okay, this is the root user. Now what you have to do is, if you want to create the cluster, first you need to install the prerequisites. Okay, so install kubectl. What is kubectl? First of all, let us see, I already told you, you install prerequisites and you can create the cluster with the prerequisites. What does it mean? Without knowing these things, how you can understand those things? First you need to understand what is kubectl, what is this EKS ETL, what is the AWS CLI. You need to understand those things first. Okay, so this kubectl is the tool. It's a command line tool. Okay, this command line tool will be used for giving the input to the cluster. Okay, it is used to giving the input to the cluster. What is the cluster? Kubernetes cluster. So you can give the commands. Okay, you can give the kubectl commands, like, for example, you have Docker. What you will do in the Docker? You will give the Docker run, you will give the Docker stop, Docker pull, Docker exec. All these commands you will give that, right? Where you will give? You will give in the Docker client. Okay, Docker CLI. Similarly, you will have the kubectl for the Kubernetes only. Okay, so here you will give the Kubernetes commands. Similarly, like we have EKS ETL. So this kubectl is for the Kubernetes client. This EKS ETL is the EKS client. Like this is the AWS related. Okay, so because EKS is the AWS service, right? So like if you take the EC2 instance, how you can EC2 instance, how you can use the EC2 instance? You can simply connect to the EC2 instance and then you can then simply run the commands there. Similarly, EKS ETL also, it is like a it's like a virtual machine. Like I can say it's like a virtual machine. There you can use the EKS ETL commands. Whatever the commands you will use, like a kubectl get pod, kubectl get nodes, like that. You can also use the EKS get nodes, EKS get pods. So those kind of commands you can use in the command line. This is related to the AWS. This is related to the Kubernetes client. This is the EKS client. Okay, now this is AWS CLI. What is this AWS CLI? AWS command line interface. This is, so if you want to perform kubectl commands, EKS ETL commands and the AWS commands, first you need to have the AWS CLI. If you don't have AWS CLI, you cannot perform these commands. Okay, not only for Kubernetes. If you want to use the any service in the AWS, like there are multiple services like S3, like IAM, VPC, like ECS, ECR, EKS, EBS, EFS. Lot of services will be there in the AWS, right? If you want to do all the operations of that AWS services from the command line, you just simply need AWS CLI. Okay, so with the CLI you can do all the things, all the operations from your virtual machines. You don't need to go to the console. Simply you can, it is sufficient. You don't need to use the console. Okay, so this is all about the prerequisites. Now what we have to do is we have to install these prerequisites in the virtual machine. Okay, so let us open the Google Chrome. Let me install this kubectl. So just simply type kubectl download. Okay, so if you run like this kubectl download, it will prompt you this instance install tool, right? Just click here install tools. Okay, now you can see three options: install kubectl on Linux, install kubectl on macOS and Windows. So always try to do DevOps operations on the Linux only. Okay, if you are working with a DevOps engineer, then better to learn the Linux. Okay, Linux distribution. Always learn the Linux distribution. So there are a lot of OS in the Linux. What are those OS? Ubuntu, Red Hat. Lot of OS will be there in the Linux distributions, right? So always try to learn any one of these distributions, either Ubuntu or Red Hat, any one of these. Okay, so install kubectl on Linux. Click this one. Okay, now you will see download the latest release. You can see the latest release with the command. Okay, always try to if your machine is x86-64, then you can use this command. If your machine is ARM64, then you can use this command. Okay, you can check these things in your machine also. If you see here you can check all these things, whether it is x86 or some other things. You can check here Ubuntu Linux this machine, and it will show you those things also. But you will know, right, while creating you will select those things, right? So from there you can understand whether it is x86 or ARM6. Okay, so now I will take my OS is x86. Now I will take this command. I will simply copy this one. Okay, copy this one. Let us open this one and copy it, enter it. It will download something. Okay, now see, it is download kubectl. Okay, now what you have to do is go to Chrome. Okay, now just x864. Now just copy this one also. Okay, paste it here, enter it, done. Okay, now just go to validate it, that binary file. Just give this one. Okay, you don't ask me about these comments. Okay, so these are something advanced concepts. We don't need to focus on all these things. What are these things, what are these things? We don't need to focus on all this. Just simply copy paste it. No one will ask you. Okay, no one will ask you about how you install it. No one will ask you. You just simply do all these things. Okay, and just do echo. Okay, it will give you okay. If it is okay, then you are doing correct. Okay, now you have to install kubectl. Okay, it is installed. Okay, now you can check the version, kubectl version client. See, this is the version. If you are able to see the version, that means you install the kubectl. Or simply you can use kubectl -v. Oh, -v is not supporting, right? -version. Oh, okay. So I think you have to use this one only, this command. So you can check the version of this kubectl. So I have installed the kubectl. Okay, now what I have to do is I have to install EKSCTL. Okay, how you can install EKSCTL? You can install EKSCTL similarly like kubectl. You just simply go to here, install, download EKSCTL. Okay, now click the first option. Okay, now just click here installation option, click installation. Okay, now go down here. You can see the for Unix, Linux is the Unix distribution, right? So copy whole things. Okay, now I will execute all the commands at a time. If you want to execute one by one, you can execute it, that is fine. But if you want to execute all the commands at a time, you can execute. How? Just simply create one file. Let us take the file name as install. You can give it a name. Just give .sh because it is a shell script. These are the shell script commands, right? Shell commands. These are shell commands. So you can use the .sh. Okay. Now enter it. It will open the editor. Now you can paste all the commands here. Now exit it. Yes. Enter it. Now you can see install. These are the commands we have added in the file. Okay. Now what you have to do is, let us see ls. Okay. This is the install.sh file I have created. Now let us check the permissions of this install.sh. Okay. How you can check? ls-la. Now if you see install.sh is the file name, you can see this has only read and write access only. So you need to give the execute permissions for this file. So how you can give the execute permissions? You just simply use the chmod command and give the execute. Plus X indicates the execute permissions. Okay. Now give the file name. Now enter it. Now ls-la. You can see the color is changed green. Now you can see X is added. That means it has the execute permissions. Okay. If you don't have execute permissions, you cannot run the file. Okay. You cannot run the shell script. Okay. Now what you have to do is, you just simply run the shell script. How you can run it? Just simply give this command. Now it will run the commands. All the commands run, it will run at a time. Okay. So see EKS Linux, it is okay. That means you have installed successfully. Now let us check the version of that EKS CTL. So how you can check the version? Just go back one step here. So here it will show you the command EKS CTL version. Let us run this command. See, it is showing 01610. Okay. So this is the version of the EKS-CTL. You have installed the EKS-CTL also. Now what you have to do is, now you have to install the AWS CLI. How you can install the AWS CLI? Again, you have to go to the Chrome. See, what I'm doing is, I didn't remember anything here. I just simply I have gone through the Google and I just simply check all the commands there and I just install those things. Okay, no need to remember all the commands. Okay, so here how you can install this AWS CLI? Just simply write this command, install AWS CLI on Ubuntu. Okay, now you will get the first option. Let's click on this option. Okay, now here if you see, it will show you the distributions. Okay, now click on the Linux because we are using the Linux. Okay, click here. Now it will give you multiple ways to install it. Okay, I am taking X86. Okay, not the ARM. Okay, just simply copy this command first command. It will download the zip file of the AWS CLI. Let's do this. It is downloaded. ls see, it has downloaded the AWS CLI zip file. So you need to unzip this file first. How you can unzip this file first? Here in this you have unzip AWS CLI next command, but you don't have unzip in this, because let us see unzip --- version. You don't have unzip here. Unzip is not found. So you have to install unzip first. Okay, so how you can install the unzip? So you have to install apt-get package and apt-get install and unzip. So first of all you need to install unzip. It will install the unzip and you can use the unzip command to unzip the file. Okay, so you can just simply copy this command. Okay, now paste it here, unzip it. Okay, now it is unzipped. Let us clear this one. Now take this command, install the CLI. It will install the CLI, AWS CLI. See, it is installed. It is installed. Now you can check the version. How you can check the version? AWS CLI - version. Oh, let us run this one. Let us run. Okay, it will give you the version. See, this is the AWS CLI version. Okay, now after this, see, we have installed everything, all the prerequisites we have installed, right? Now what we have to do is, we have installed the AWS CLI, but we haven't configured the AWS in your virtual machine, because you have to access the AWS, right? So if you want to access the AWS, first you need to configure that AWS within your virtual machine. How you can configure it? So for configuring the AWS within your virtual machine, you have to use the command called AWS configure. Okay. So if you use this command, it will ask you the access key and the secret key. But how you can get this access key and the secret key? First you have to go to the AWS console. This is the AWS, not this one. This is the AWS console, right? This is the EC2 instances. Now what you have to do is, first to, if you want to get the access keys, you simply go to IAM, Identity and Access Manager. Just go to IAM. Here you let's see what it gives. Yeah, see here, if you go to let me show you those things. Okay, policies, go to policies, not the policies, I think it's not the policies, I think it's something else. Let me open, let me go back, one second here. Account settings, not the account settings. IAM, one second, go to users. Okay, do one thing, don't go like this, it's very identifying that feature is somewhat difficult here. So what you have to do is just simply go to the top right corner, you have one option called this one, right? Click here, you will see the security credentials option. Just click security credentials here. Okay, it will redirect to the IAM, okay. Now here you can see, there is an option called access keys. Okay, I have already one access key. Okay, you can create one more access key. So mostly you can create only 2 access keys, more than 2 you cannot create. So let me create one access key here. Okay, let me click this one and create access key. See, this is the access key, just copy it. Okay, give it here. Okay, enter. Now let us take the secret key also. Okay, copy it, enter it. Okay, now you can give the any reason name, but I will take the default one, no issue. And the default output format you can give either it is a JSON or whether it is YAML, you can give anything. I'm giving JSON. Okay, no issue. Okay, so I just configured my AWS in the virtual machine. Now let us check whether I am configured with AWS or not. How you can check? You should access all the services, all the resources from here. You don't need to go to AWS console. You can control everything from here because you have configured the AWS here. Okay, so how you can check whether you have configured that AWS here or not? So let us check whether I can able to access the S3 or not. So I will use the command AWS S3 ls. See, these are the containers, these are the buckets I have in my S3. Let us go to S3. S3 is a storage account. Okay, so storage service in the AWS. Here you can see all the buckets. Okay, see, these are all the buckets: code pipeline, flow logs, MT15, NGO talent. So here you can see all these things: code pipeline, flow logs, MT. So I can able to do all these operations from here also. You can create the bucket, you can delete the bucket, you can update the bucket, you can store the files in that bucket. So all these things you can do from the CLI only, because I have configured everything here in the virtual machine. So this is okay, right? So I have set up CLI here. Okay, now what I'll do is, this part is completed. If you want to check the credentials, just simply copy this command and just simply execute here. We will simply get the credentials. This is the your user ID, account ID. This is the IAM ARN. Okay, ARN means Amazon resource name. Okay, this is the Amazon resource name. This is the root. Okay, we are in root. This is the account ID. Let us check whether it is. So it's a at the end we have 888 and at starting we have 327, right? Let us check whether it is or not. Click here. See, 32788. This is my account ID. So you can check the account ID also. Whether you have connected to the particular account or not, you can check this. Okay. So this is the setup of AWS CLI. Okay. We'll get.
Also, we need one help.
Yeah.
We need one help from.
Yes. Yes.
If you have any sample program pipeline for end-to-end, it could be helpful for our project.
I will give you that sample pipelines for you for this Jenkins. I will give you.
Okay,
I will give you
okay,
that document for that. Okay, you don't worry about that. That is mandatory.
okay,
Okay,
okay.
that is mandatory. If I don't give you that, you won't understand.
Mm.
Okay, I will give
Yes,
you.
yes.
Don't
We
worry.
need to understand the pipeline between all the
Yes, yes, I will give you those things. You
users.
don't worry. Okay.
Okay, okay,
So,
okay.
any doubts you have till now, you guys, Francis and you?
I have
Marvin?
no doubts, Ramana.
Yeah, yeah, that's fine. We'll meet next
Okay,
week. Yeah,
sure.
yeah.
Okay,
Okay,
sure.
okay,
Thank
okay.
you.
Yeah, bye, bye.